This is the last unit, last lesson for this unit, and we're going to learn how to rewrite equations in formulas. Sometimes you'll have to deal with equations that have more than one type of variable. Perhaps it has both a y and an x, and you can't combine them, but maybe you need to get one of them by itself. Formulas are are typical for you that have that need. So how do we do that? So we're going to specify a variable. So in our example, you're going to be asked to just solve for y and take a look at the examples. You can see both y and x. So how do I get y by itself? It's the same strategy. What you have to do is look at the other variable as if it was like a number term or something, and you want to get it to the other side. So it's not the strategy of variables on the left, numbers on the right. It's the variable we are looking at on the left and everything else on the right. Okay? And so how do I do that? How do I get y by itself? What's happening with y? Well, we're multiplying it by 2, so that's got to go. We're also adding 5x to it. So we've got to get rid of this 5. Remember, undo addition first or subtraction. We're going to get rid of this. So I'm going to subtract 5x from both sides. Now I do want to note on the right side, I can't really combine this. This is not 6 minus 5. It's 6 minus 5x. And these are not like terms. 6 does not have a variable x, so it can't be combined. So when I rewrite it, I'm just going to rewrite them as two separate terms on the next line. So let's do it. All right, so 5x minus 5x, that's 0. And so the left side simplifies to just 2y. And equals. On the right side, two separate terms. You can put either one first. I will tell you, you want to get in the habit of putting the variable term first. So I'm going to write this one first, negative 5x. It's not wrong to write it second, but in the next unit, we'll be putting it first. And I see I'm really close to the line, so I'm going to squish in the positive 6, so I write plus 6. And then I have the 2. I need to divide by it on both sides. So divide by 2. Now this is a quantity. Whenever you see addition or subtraction of terms, that means you're going to divide everything by 2. So that's, I write it as one long line under both terms. Now I know 6 and 2 can be reduced, but 2 doesn't reduce with the 5 in a simple way, right? So I can't just go, oh, I'll just cancel the 2 with the 6. That's what I want you to be careful about. We're really dividing everything here by 2. So we are going to distribute that division if I decide to simplify this. All right, so the left side, 2 over 2 is 1y. The right side is negative 5x plus 6 over 2. So that you're allowed to leave that as the simplified form because the 2 doesn't divide both of them easily. If it did, if the 5 was an even number, then I would be required to do an extra step of reducing. All right, but let me show you how that would work out. So again, I'm just going to split this up and write this as two separate fractions. Y equals negative 5x over 2 plus 6 over 2. Now the 6 over 2 we can reduce. And so that's just 3. 6 divided by 2 is 3. This is not reducible. And it's also traditional to separate this as the fraction part times the variable. So I'm going to write that as negative 5 halves times x, and then bring down the y. And that's a traditional form, and you'll see why in the next unit. Perhaps you've already studied linear equations, but that's a preview of what we'll want to be able to do. All right, so let's take a look at what we have next. We're going to solve for y. Sometimes it helps you to circle the variable, kind of keep an eye on it. So here's the y we were trying to isolate. Circle it and keep a focus on that. Get that by itself. So let's undo addition, subtraction. We have minus x, so let's add x to both sides. So the left side, the x's add to 0, leaving me just 5y. Bring it down. Again, 10 plus x, can't combine them, so I'm just going to rewrite both terms on the next line and put the variable term first for conventional purposes, that's all. And positive 10, so plus 10. Okay, now divide both sides by the 5. So left side is just y equals. Can you do this in your head? We have, what's the number next to x? What's our coefficient? If you don't see it, it is a 1, right? So this is 1 over 5 times x. That's my first term, 1/5 x. And then this is plus 10 over 5. 10 divided by 5 is 2. So plus 2. All right, so there is our answer. Next one. Again, focus on the variable that we're solving for. So I see it's right here now. I'm going to circle it and isolate that. What do we need to get rid of? We've got the 4 that's multiplying it. Well, that's what we do second. I'm going to undo that next time. But we've got this 4x here. It's not being subtracted from it, right? This negative goes with the 4 attached to the y. The 4 here is positive, so this is being added to this term. So we're going to undo addition by subtracting 4x. 4x minus 4x minus 4x. Okay, so 4x minus 4x is 0. And then 0 added to the next term preserves that term, so it's just negative 4y equals, and then these two are not alike, so I will just bring them down with the x variable term first. Constant term comes next, so plus 1. And then we divide by negative 4 and simplify. All right, 1y equals, what's this reduced to? Negative 4 divided by negative 4, 1x, so just x, and 1 over negative 4, and so that's negative, so a positive over a negative is a negative, so negative 1/4, not 4. 1 is in the numerator. Okay, what reduces to 4? So how would I write the number 4 as a fraction? Hopefully you thought 4 over once. Remember, you can't just put a 4 here. Okay, keep that in mind. All right, so that's our answer. All right, let's try an application problem, another geometry style problem. So here's a formula. All right, so something you'll calculate when you take geometry is surface area, and this is surface area of a cone. We're going to draw a picture of that. And here is a formula. So a lot of mysterious writing here. So it's like calculus or something, right? Well, it asks us to solve for the letter L. So that's a cursive L, just to distinguish it. It's not the number 1, so I wanted to make sure that's clear. So it's a cursive L. What are all these parts? Well, big S is the surface area. Let me define all this. This is called defining your variables. We have a lot of them here. We have little r. Well, what's pi? Now, pi is a number. Pi is 3.14 ... continues forever. That is not a variable. R is the radius of the base, which I'll show you in a moment. And then finally, there's the cursive L, which is called the slant height. All right, so what is this figure that we're dealing with? Well, a cone, so let me draw it like this. I'll draw it upside down. You know, like an ice cream cone, right? Like a sugar cone. So it has a circular base. So this is a circle at the bottom, and this is the invisible part because it's a solid. And every circle has a center, and R is the radius. So from the center to the edge, that's R. The slant height of the cone. Well, this is from the apex here down to this edge, so to the base. That's called your slant height. And if you know those two measurements and you put them into this formula, then you can determine the surface area. What's surface area? Well, that's the area of the base, the bottom. You know, it's like how much materials do you need to make this cone? Is what we're asking. So, and then so surface area includes the base, and it also includes the cone part of it. So this edge, this stuff here, goes all the way around the cone. All right. So we are supposed to take that formula and solve for L. And so let's rewrite it. Now remember what that means. I'm going to circle this variable and focus on that. I want to get that by itself. Okay, so everything that is not L has to go to the other side of the equal sign. That's how you think of it. Just move it over there, right? Well, how do we move it? How do we do that? Okay, so first this term right here, there's a pi and an r that are multiplying it. So remember, we're going to undo multiplication later. This, and then added to the L is this term here. So let's undo this first. So it's a positive pi r squared, so we can undo that with subtracting it from both sides. So minus pi r squared, and then minus pi r squared on the left side. All right, so on the right, that simplifies, opposites add to 0. And on the left, I have two terms that are not alike, so I write them separately. So I have surface area, and the order doesn't matter, so I'm just going to do write it as a subtraction problem, s minus pi r squared. All right, and so what am I left with? 0 plus this term. I'm just left with pi times r times L. We're really almost done now. Remember, on the right, trying to get that L by itself. Well, what's happening with that L? We're multiplying it by two different values. So let's undo that multiplication with division. Divide by pi, and divide by r at the same time. Divide by pi, divide by r on the left side. So pi divided by itself is 1. R divided by itself is 1. So we have 1 times L, which is L equals this expression on the left side. And remember, I'm not going to just reduce these. I'm not going to cancel these pi's. I'm not going to cancel any r's here. Why? Yeah, you should notice this is two terms here. The pi times r is dividing both of these. So you'd have to split it up. I'm just going to, since it's a formula, I'm just going to leave it in that form. But I am going to do convention and put the variable I'm solving for on the left. So I'm just going to swap sides out. So L is equal to the surface area minus pi times r squared divided by pi r. And that completes the formula you're supposed to achieve. Time for more practice.